Okay, in this lecture we're going to examine statistical power in analysis of variance. As mentioned earlier, power is the likelihood of finding statistically significant differences given that such significant differences actually do exist. Put another way, it's the likelihood of rejecting the null hypothesis when it actually should be rejected. So, power, therefore, is directly related to type 2 error. The more power in a study, the less chance there is to identify a non-significant difference if such a difference actually exists. Whereas type 2 error is expressed as beta, power is typically expressed as 1 minus beta. So there's an inverse relationship between power and type 2 error. The more power, the less chance you have of making a type 2 error. The more power, the less chance of you missing a statistically significant effect. Power is dependent upon three factors: sample size, effect size, and alpha level. We've already demonstrated the effect of sample size and effect size. So as discussed in the lecture on effect size, large sample sizes increase the likelihood of finding statistical significant differences. So if you have a large sample size, you have a lot of power in your study. All right. Often statistical tests that show significance, not because the results are meaningful, but simply because the sample size is so large that they pick up on very minor differences. Alpha level also has an impact. When an alpha level is at 0.10 as opposed to 0.05, the critical value is lowered and the likelihood of finding a statistically significant difference increases. In other words, the observed value is more likely to be larger than the critical value. As the likelihood of masking a type 1 error is increased, the likelihood of making a type 2 error is decreased. So there's an inverse relationship between type 1 and type 2 error. The less type 1 error you have, the more type 2 error you actually have. So while procedures exist to decrease the chance of making a type 1 error, like a Bonferroni adjustment, researchers do run the risk of increasing the chance of making a type 2 error, especially if you have smaller sample sizes. So keep in mind that effect size is pertinent. Although the researcher cannot usually control effect size, the greater magnitude of the differences between groups, the fewer participants are needed. So if you believe that you're going to have a large effect size in your study, you don't need to have as many participants in your study. So keep in mind also that power is influenced by error. The less error measured in a study, the more power there is. While issues like the magnitude of a treatment effect or error variance are very rarely influenced by the researcher. You can't control that. You do, however, control an alpha level, and you can decide whether to make that alpha level smaller, as in more conservative, or whether you can allow more type 1 error in your study. That runs risk, however, if you allow for more type 1 error in your study. You usually don't want to do that. So the easiest method for increasing power in a study is to increase your sample size, and that is something that the researcher can control. So keep in mind that research methods may be wrought with emphasis on statistical significance. Sometimes we overemphasize finding statistical significance. And so we see this trend of discounting meaningful findings because no statistically significant differences or relationships exist. We tend to overemphasize the results of statistical significance, and we really need to be emphasizing more on effect size. In addition, sometimes knowing where not to look for answers can be just as important as knowing where to look for answers. So simply because we don't have a significant result doesn't mean that the research isn't important. That does inform future researchers where not to look, what variables not to test. All right. Also keep in mind that moderate and large effect sizes may be found when statistically significant differences do not exist, and this is usually a result of a lack of power. Usually your sample size is too small, and as a result, your study may not be generalizable if your sample size is too small. Right? So the best scenario is to have an adequate sample size and have statistically significant effects. When you have sufficient power in a design, that can be an important factor in basically saying whether or not your study is important and ultimately publishable. In social science research, power is usually deemed sufficient at 0.80. In other words, having an 80% chance of finding statistically significant effects. So that does allow for a 20% chance of making a type 2 error, which you can minimize by having a large sample size. There are 3 ways to evaluate power. We can do it at the beginning of the study, before we even do anything. We can do it after the fact, and we can do what's called a sensitivity analysis. And we're going to talk about all 3 types here. The purpose of an a priori power analysis is to identify the appropriate sample size needed to do the study. So if the researcher can estimate what kind of an effect they're hoping to find, such as a small, medium, or large effect size, and how many groups they're going to have in the study. In addition, you can also set your minimum level of power, which is usually 0.80. That's what Cohen suggested. And you identify your alpha level in your study, of course, at the beginning, before you even analyze anything. And so by following these steps, you can actually identify how big your sample size needs to be in order to find statistically significant differences if they actually exist. Hence, by doing an a priori power analysis, you can avoid having that large effect size but no statistically significant differences, which would be an unpublishable study because your sample size would be too small. So this tells you, if you're going to do a study, how big does your sample size need to be? That's important information. The second type of power analysis is called a post hoc power analysis. And this is used to address whether or not you had adequate power. In order to do a post hoc power analysis, you identify the effect size in your study. You've already evaluated your data and you know your effect size, you know your number of groups, you know your total sample size that you had because you've already done the analysis, and you identify the alpha level of your study. And this tells you whether or not you have adequate power, whether or not power is greater than 0.80. And then finally, a sensitivity power analysis tells you what's the necessary effect size in order to detect statistical significance. Again, you set your minimum power at 0.80 and you identify the number of groups in your study and your sample size and alpha level. And this tells you what type of effect you need to have. So if you didn't find statistically significant differences, a sensitivity analysis can tell you what you actually needed in order to find those differences. Or if you do find differences, a sensitivity analysis can tell you what your effect size needed to be in order to find those differences. What's the minimum effect size you needed? So the a priori and the sensitivity power analyses are actually very helpful. The post hoc, not so much, because obviously if you don't have a statistically significant effect, you don't have adequate power. So to review, power is an underreported but important aspect in social science research. It can be a little complicated to compute by hand, but the interested reader is referred to pages 10 through 12 in my note pack. You should download a free program called G-Power, which will conduct these types of power analyses we discussed, and also watch the G-Power tutorial available on my website to learn how to use G-Power.